So now we are going to see the rectangular form of a complex number. So go for the definition. A complex number is of the form x plus iy. A complex number is of the form x plus iy. Here where x and y are real numbers. So x plus iy is a complex number. In that x and y are real numbers. Okay. So x is called the real part of the complex number and y is called the imaginary part of the complex number. So what is x? We can write x as Re of z. Z is a complex number. So Re of z means it's a real part of z. And y is the imaginary part of z, that is Im of z. You look at this. X and y are real numbers. X, the term without having I, is called the real part. X is called Re of z. And the term associate with I, okay, that is called the imaginary part of z. Okay, but you just see the example. I have taken z is equal to alpha plus I beta. It's a complex number. Here the imaginary unit I is present. So this number is a complex number. I have taken as this as z. Now I am going to find what is Re of z. What is Re of z? It's a real part of z. How to write the real part? The term without I. So you look at this. This is the term. In this term we don't have I, so this is the real part. A real part of z is equal to alpha for this complex number. And imaginary part of z, the term, we have to see the term with I. So this is the term we are having I. So the coefficient, that is beta alone, is called the imaginary part of z. You should not write beta I. While you are writing imaginary part of z, you have to write beta alone. This beta term is joined with I. So we have to see the term having I, but you have to write only the coefficient for imaginary part. Okay, see the next example. Z is equal to minus 2 plus I. Okay, so what is the real part? Real part is minus 2. Can you say the imaginary part? The imaginary part is here, it is the coefficient is 1. So the imaginary part of z is 1. While you are writing imaginary part of the complex number, you should not write I. Only the coefficient of I has to be written as imaginary part of z. Okay, next we are moving to the organ plane. Okay, so the complex number z is equal to x plus iy is uniquely determined by the ordered pair of real numbers x comma y. Now already I have said x comma y are real numbers, so we have to write as a ordered pair. That means the first one is a real part, the second one should be the imaginary part. So the complex number can be determined as a ordered pair x comma y. Okay, so for example, the complex number 3 minus 8i is equivalent to 3 comma minus 8. Okay, so the next one. So we can associate a complex number with the point x comma y in a coordinate plane, that is xy plane. So for that we have to consider x-axis as real axis and y-axis as imaginary axis to represent a complex number. Okay, then the xy plane is called the complex plane or organ plane. So if you consider x-axis as real axis, y-axis as imaginary axis, means that xy plane is called the organ plane or complex plane. So we can represent the complex number as points in the organ plane. So see that this x-axis I have taken as a real axis and the y-axis I have taken as a imaginary axis. So you see that this point represents a complex number 2 plus I. So 2 plus I means how it will be determined as a point 2 comma 1. Yes or no? Upper real axis I have taken 2 units and the imaginary axis I have taken 1 unit. So therefore this point is represented by the complex number 2 plus I. In the same way, you see that this complex number minus 1 plus 3I, how it is uniquely determined as a point? Minus 1 comma 3. So real axis I have taken minus 1 unit and the imaginary axis I have taken 3 units. So this point represented a complex number minus 1 plus 3I. Okay, so take this. The complex number can be represented as position vectors. Okay, so 2 plus I, the same point. So here I have represented as a position vector starting from origin to this point, and this complex number also I have represented by using the position vectors. Okay, so see that next topic, algebraic operations on complex number Z. Okay, so here the first operation is scalar multiplication of complex numbers. So Z is equal to x plus iy. If this is a complex number and k belongs to R, k is a scalar. So the scalar multiplication of the complex number is defined as kz, kx plus kiy. For example, I have taken k is equal to 2. So 2z, how it will be written? It is 2x plus 2iy. So the 2 has to be multiplied with these two terms. That is a scalar multiplication of complex number. The next algebraic operation is addition of complex number. Here I have taken two complex numbers. So the addition z1 plus z2 is defined as like this. So here the same way addition as usual, we have to add the like terms. So x1 is added to x2, x1 plus x2. So these two terms having I. So and I have taken as common, so the answer is y1 plus y2. It's addition of two complex numbers. The next operation is subtraction of complex numbers. So it is defined as z1 minus z2. So x1 plus I y1 minus x2 plus I y2. As usual, x1 minus x2, the same term is subtracted. In these two terms, these two terms I is common, I have taken out, so y1 minus y2. Okay, come to the multiplication. So it is defined as z1 into z2. So I am going to multiply these terms. Okay, as usual you can multiply and you can get the 4 terms, then you can simplify. Okay, so in this way also you can do. Otherwise, for the calculation to be easier, so I have written like this. You see that here first, while you are multiplying the complex number, the complex number should have real part as well as the imaginary part. Now I am going to say the real part of z1 z2. How to write the real part of z1 z2? You take x1, that is the real part of the first complex number, has to be multiplied with the real part of the second complex number. So x1 x2. Okay, next one, you consider the imaginary part. Imaginary part means the term having I, adula and the coefficient mattumda you have to consider. So y1 into y2. So when you multiply these two, y1 y2, here what I have written minus. Why I have written minus means I into I is I squared, so that's why minus. But how to write the real part of z1 z2? Okay, what you have to do, real part you multiply pannu, then imaginary part multiply panni, you have to change the sign. Why you are changing the sign? Because of I squared. Now I obtained only the real part. Next I should have a imaginary part of z1 z2. So for imaginary part means you should have I, so I have written I. So how to write the imaginary part of z1 z2 means you take the real part of first complex number, it has to be multiplied with the imaginary part of the second number. So x1 y2 plus, in the same way, imaginary part of the first number has to be multiplied with the real part of the second number. So x2 y1. If you do like this, so you will arrive the answer in the next step. Okay, so see that I have written the notes. So first here what I have said, I have written here real part of Z1 Z2. Z1 Z2 multiplication, product of two complex number. Adula real part, if you want to write real part, what you have to do? Real part into real part, real part into real part, plus what you have to do? Imaginary part into imaginary part, and you have to change the sign. Multiply the imaginary part of those two complex numbers and change the sign. Next, you have to get the imaginary part of multiplication of two complex number. So see that real part of the first number and the imaginary part of the second number. Real part of the first number into imaginary part of the second number, plus in the same way imaginary part of the first number into real part of the second number. Okay, see I have given this example here. See, I have taken this problem exercise 2.2 first problem la fourth subdivision. Z is equal to 5 minus 2i and w is equal to minus 1 plus 3i. Then how to evaluate ZW? ZW, it's a multiplication of these two complex number. So I have written the product here. So what I said, so first you are going to write the real part of ZW. So real part into real part. So 5 into minus 1 is minus 5. Next what I said, multiply the imaginary part of those two complex numbers and change the sign. So here what is the imaginary part? Minus 2. It has to be multiplied with the imaginary part of the second number. So it is 3. Minus 2 into 3 is minus 6. Here I have written as plus. So I have changed the sign. So I obtained the real part. Then imaginary part. Imaginary part means you have to write I. So I into. So what you have to do? Take the real part of the first complex number and the imaginary part of the second one. So 5 into 3 is 15. The same way minus 2. First number order imaginary part has to be multiplied with the real part. Minus 2 into minus 1 is plus 2. So the answer is 6 minus 5 is 1 and 15 plus 2 is 17. 17 into I is 79. So we can reduce the steps while doing the calculation. You can easily work out by using the this method. Okay, thank you students.